In this problem, we're asked to graph what's called a piecewise function. It's called a piecewise function because it's in pieces. In this case, we know that there's three pieces. When you first look at a piecewise function, you just count these rows here. 1, 2, 3, there's 3 rows. The next thing you want to look at is where are these 3 different graphs going to break up? Where's the thing going to be split? In this case, the first split occurs at -2. It's saying here when x is less than a -2, look like this graph. When x is between -2 and 0, look like this graph. But when x is greater than 0, look like this graph. So we've got a split at -2 and another split at 0. So we're going to want to pay attention to those. What happens here at -2, and then again what happens over here at 0. So we'll really watch those. Sometimes when you look at these problems, the authors, they type them in a little different than what you're used to seeing. So I retyped this one to make it look just a little different. Take this first part here. Normally we think of this as a parabola. It's x squared. It's a parabola that's facing down. And normally when we think of it, we have the constant coming afterwards. So it's a facing down parabola that has been translated or moved up 4. The next one is a line. It's just to the first degree. So like y, this is your y equals mx plus b. The slope here is 1. So it's a line that's crossing the y-axis at 3. The third piece is again a parabola that's been translated up 1. Now we can't just make a parabola, a line, and a parabola because they don't show the whole part. So again, this one is only showing until it gets to -2. This one's only showing between -2 and 0, and this one's only showing from when it's greater than 0. So we can go ahead and we'll start with the first piece. Again, piecewise functions. We'll break it into pieces. The first piece comes in, and it doesn't look like a lot like a curve here, but it is a curve. When I drew it, I didn't bring it quite to the -2, and here's why. Here x is less than -2, but not equal to. So what I'm going to do here, and I kind of already accidentally filled it in, but this would be an open circle. You can have an open circle right there. Then the next piece is a line. You might want to plot a few points for each of these to figure out where they would be. But the line, in this case, the line would go on, again, we knew it would cross at 3. It would go on both directions, except since we're only showing pieces, I'm only going to show the piece from -2 to 3. Now I need to look back at my inequalities here. It's when x is greater than or equal to the -2. So here, this is going to be a closed circle. But here, less than 0, this is going to be an open circle. That piece is done. So then we go to our third piece. Our third piece, again, is a parabola translated up 1, but we're only showing it for when x is greater than or equal to 0. So here's that piece. Normally, again, the parabola, we'd see the whole thing, but we're not showing the whole thing. We're only showing this piece of it. This is greater than or equal to, so I would put a closed circle right there. So again, you should have an open circle here, closed there. Open circle here, closed there. The reason we have to pay attention to the open and closed circles is because it's a function. It has to be able to pass the vertical line test. If I pass a line through here, it can only touch 1 point. If I had closed this one and that one, it'd be touching 2 points, which means it would not pass our vertical line test. Therefore, it can't be a function. But in both cases, we've got our open and closed circles. It does pass. It is a function, and that's our piecewise function.